So, resonance. Okay. What we're doing with resonance is you can give a molecule extra stability. It'll be much more stable, and you lower its energy. That's a good thing, to lower energy. And if you can resonate. And what's resonance? Well, all you're doing is you're just, no way. There it goes. You're moving a double bond around. Within the molecule. That's all it really is. You can't move the atoms around. You can't move the atoms around, but you can move a double bond around. Okay? And that's really what resonance is happening. Here's a good example. You'll see this a lot in organic chemistry. And you'll see these kind of structures a lot. And they don't like to draw what element in organic chemistry. You see all these, like each corner here is really a what? A carbon. Those are carbon atoms. For some reason, I don't like to draw them. I don't know why. Right? I guess it takes more work. But that double bond just moves around inside that ring. And so instead of drawing both of these structures, they just draw one of them. And they call it aromatic. Resonance. So the double bond's moving around in there. Neither one of these is true. It's kind of something in between. So whenever you can do resonance, you do that. So for us, we're more messing around with this type of structure. Annabelle, do you recognize what this polyatomic ion is? Has a CO3 with a what charge? -2. And its name, because we have to this, right, Erica? The darn final exam is going to be here before you know it. What's the name of this? Oh, carbon 8. Carbon 8. Carbon 8. Okay. So pretty much what we're messing with is, well, heck, why can't the double bond just be here instead of on this spot? Or why can't it be over here? Right? So there's actually 3 structures for this thing. None of them are right. The real answer is between them all. So and that's resonance. So what we're going to do is illustrate that today. Now, if resonance is just moving a double bond around, which elements form double bonds, Katrina? Carbon, oxygen. Well, now she threw me off.
Nitrogen.
Yeah, I have to do CNOS. Yeah. Otherwise, I get screwed up. Carbon, nitrogen,
Oxygen.
And sulfur. CNOS. So you can only be moving double bonds around these guys, right? Not between anything. Let's try one of these together, and then we'll jump down to something else and do it together before we go to the boards. Let's do carbonate. Okay. Let's draw the resonance, draw the Lewis structure for carbonate, and all the resonance structures here. So you put C in the middle. Now, something is coming up. All class today is not just about drawing resonance. It's also about compounds that break the octet rule. If you break the octet rule, Jorge, that means you might have how many electrons around you? If you're an atom and you're breaking the octet rule in a Lewis dot structure, it could be less than 8, or it could be more than 8. Exactly. Okay? So we'll do one of those, and then we'll go to the boards. First, let's knock this one out. Carbonate. So carbon, we have to count up the what electrons? They start with a V, Oscar?
Valence.
Valence. Carbon has, Alejandro, how many? 4. And we've got 3 oxygens. 3 times Shelby. Each oxygen has how many valence? 6. Okay? That's 18, 22. But, Ellison, I have a -2 charge, so my total really is 24. I have to add 2 more because I have 2 extra negatives. 24. Okay. So, since I know what's coming up, I strongly suggest drawing Lewis dot structures this way. What's this? The Smith way here. Connect them. Make octets on everything surrounding the center atom. So that's those 3 oxygens. So I have to put 6 electrons around each one. Okay. Now you stop, drop everything, and you count. Anything left over, you put on the center atom. Okay. Now each oxygen has an octet, so really I don't have to count by 2s. I can just count by, bless you, by 8s. I've got 24 on there, right? Because each oxygen has 8 around it, so I've got 24. So I'm done. If I would have had more, I have to put it on the center atom, but I don't. I'm done. I have 24. Who's not? Now you look and say, okay, is anybody not happy? Carbon doesn't have an octet. How do we fix the problem? How do we fix the problem? Double bond. Now, do you recognize there's actually 3 structures I can draw here for this double bond? Yeah. So let's draw one of them. It doesn't matter which one you erase. You have to draw 3 of these structures. There. Another one where the double bond is over there. So draw all 3 structures. Oh, and don't forget the bloody brackets, because you have to have a -2 charge overall in this. Okay. So you have your 3 structures. Now, Danielle, you'll still get a point or so taken off if this is your answer. None of these 3 structures are right. The real answer is somewhere in between, so you're supposed to do what between each one of these structures? Draw a little what? Show that it's bouncing around between them. Double-headed arrow, right? Double-headed arrow. To show that it's bouncing around between all 3. None of them are right. It's something in between. It's resonating. Lower energy. Okay? So before we go to the boards, I want to show you one more. Well, I want to show you 2 more things before we go to the boards. First, I want to give you the structure of this compound. And I do not remember what the homework expects you to remember. So that's why I'm just going to show you this now. Do you remember what kind of compound this is? It has an H out front. An acid. So an acid, Jonathan, means that H falls off really easy or not? It's an acid, so the H needs to flop off, right? And react, do its thing. Well, that means the H has to be attached to something really electronegative. And there isn't any fluorine in it. Fluorine's the most electronegative element on the planet. But Tegan, what is really electronegative? And it's in this compound. O. So this H in these acids is always attached to an O. So you want to write N as a center atom and put everything around it? No. You have to attach, and that's kind of right. Everything is around the N, but that H has to be attached to an O. So to do this structure right, you have the 3 O's, but realize that H has to be attached to one of the O's. It doesn't matter which one either, because you just rotate the thing and you'll have the other ones. So it doesn't matter which one you attach it to. So that's your structure that's where you start to write the resonance descriptions. And notice, it looks like, we'll do this one, Shelby, but just to get you thinking about it, in this compound, it's called nitric acid, how many possible resonance structures do you think you might end up writing? She says 2 first. I could see the 2, right? Double bond here, double bond there. But then you could also have a double bond over here, right? Just make sure you're obeying that octet rule. So there's 3 possible ones when we do that on the boards. I just want to jump down to something like, let's just do this one. Okay. Because Diana, it's going to be confusing on the quiz on the exam. You don't know whether they want you to do resonance, just draw Lewis structure, or what. So when you look at this compound, I3 minus, can it be a resonance problem? Can it be a resonance problem? We're going to have all these structures and drawing arrows between them. It can't be. It cannot be. Why? It doesn't have, which elements aren't there? CNOS. So it's just drawing a structure and you quit. So if you're going to draw this structure, first you get the total. So Christian, what's the total valence electrons there? 22. Very good. 3 times 7 plus 1, 22. Put I in the middle. Well, you draw it bent, you really don't know. Right? 22. And remember the rule. Connect them, octets, everything surrounding, anything left over, put on the center atom. Right? So Daisy, how did you end up with drawing this at some point? Then how many electrons did you end up putting on that center atom? 2 dots? My total is only, though,
I mean, like 2 up here, 2 down there.
2 up there, 2 down there. Now what's my total? It's only 20. You got to keep going. Where do you put them? You put everything on that center atom. And it's really going to be helpful to write those lone pairs this way, so that when you count, you can count 1, 2, 3 lone pairs on that center atom. That's going to be really helpful for the next class period. Okay, so you keep them paired up and kind of separate them out. Oh, and I forgot the brackets, right? Okay, so that's the game we're playing at the boards the rest of the hour here. We're going to first draw some Lewis structures, some resonance structures, and then this kind of thing. Yep.
It can have more than 8.
Yeah, because remember Jorge said it can have more. It's breaking the octet rule. It can have more than 8, or it could have less than 8. So just follow the general game plan, and that's counting up the total, connect everything, make octets around everything that's surrounding the center atom. Any electrons left over, you put where? On the center atom. Okay. And resonance only works with which elements? CNOS. And you only do resonance if you need to, right? I mean, if you have to make a double bond, you make it. Okay, so let's go back up and go ahead and get started. We are over here, EX1. So help each other out, and this will go quick and painless. So remember your structure for A on EX1 is N in the center, but H has to be on one of the oxygens, not on the nitrogen. Yeah, start with this one. Skipping ahead, young lady.
What am I supposed to do?
We're doing this one first.
Oh.
Otherwise, that looks right. You save it for the next one. Then you have to erase it. So what's your total on nitric acid? 24? Yeah. Hopefully you're getting 24 as your total. So but if you do it this way, N has 2, 4, 6, 8, 10. It's only one double bond at a time. And start out by not doing any double bonds at all. Just get 24 on there. Then it's a lot easier to move stuff around. So it's octets on everything surrounding. It's octet on that. And now you count up. I bet you've got 24. Right? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So now, who's not happy? Yeah, there you go. So there's 3 places. You're going to have to draw 3 structures. So for this nitric acid, you should be drawing 3 structures. Good, you got 24. Well, you're short. You need one more. 24. Now you've got 24 on there. Now, is everybody happy?
Yeah.
Wait,
not
and so how do you make them happy? You can erase this one, double bond. Draw another structure. Erase this one, double bond. Draw another structure.
Is this
one of those,
like this one? Where we have
yes, you have to have arrows in between all 3 of those structures.
That's resonance.
Resonance. That's resonance. Yep. So there will be 3 resonance structures in this. And you need to have arrows in between. Yeah. It's a good deal. Perfect. Perfecto. Looks good. I just need your arrows.
Do I still have to draw the brackets?
No, brackets are nice, but you don't need them. You just draw your arrows. I think the only time they're absolutely necessary is when there's a charge. Okay, start out, Daniel. I would start out like.
Yeah, I had a 2.
Okay, go back to your starting point then. Okay, go back to your starting point. Okay, this was your starting point, right? Okay, so N isn't happy, right? He's got 2, 4, 6. So just do one at a time. Because if you do one at a time, now N's got 2, 4, 6, 8. He's happy. So you have to draw that structure. Okay, put it back. And then you have to draw another structure where you erase this one and made a double bond.
So it was all the possible?
Yes, it's all 3 possible structures. No, H is done with 2 because he matches helium. So H is always done. Whenever you draw one bond to H, you're done. He's got 2.
Okay,
So you're going to end up drawing 3 structures total with double arrows in between. Oh, you have your, right? He's not there.
Oh.
Now, hang on. Do one thing at a time. In other words,
Should I put it all like that?
yes, you could. You could just start like this. Yeah, that might be easier because then once you erase one, then you put it someplace right away. That way you keep your total right. Yeah, so you could just draw them all like this, and then you won't lose your total. Yeah, I should need 2 more of that. Oh, this one, there's not a bond there.
Oh, oh, the nitrogen?
Yeah,
Oh,
it's
okay.
in nitrogen. Okay, good, looks good. Good, very good. Yep. Yeah, it looks good to me. Good. I count 24 as your total. Right? Is 16 and 16. Sorry. Yeah. Yeah, there's only two. Yeah, 24. There you go. Yep, and then draw it again, but the double bond's up here. Draw it again, put the double bonds there.
The same way, right?
Yep, exactly the same.
And then we'll put the brackets and then the...
Yep,
Okay.
double arrows. So when you do this, it'll be better if you kind of make a triangle or something with those lone pairs, because you want to be able to. Yeah, there you go. You want to be able to see it crystal clear that there's 3 lone pairs. That'll help you out later on. Good. Oh, sorry. I think it's in here. Oh yeah, you're right. Yeah, there's 3 structures. Yeah, you're right. Keep going. You're good. Oh, this guy doesn't exist. There's no bond there.
Okay.
Yep. And then there's one more structure, because that you can move the double bond up here. Notice how you just can't move the double bond here, because then carbon would have 2, 4, 6, 8, 10.
So that one would only have 2 guys.
So yeah, this is only going to have 2 structures, 2 resonance structures. Yes.
Right here, right?
Yep. Yeah, so just make sure that it's easy for you to see that there's 3 lone pairs, and then it's good. Well, if you could try it, but see if you did, you'd have 2, 4, 6, 8, 10. Carbon would be breaking the octet rule, so you don't do it. Got double bond happy. Uh-huh. Oh, carbon. Sorry, this guy's done when he has 2. Because then he matches helium. Everything wants to match a noble gas. So hydrogen's done. Once you bond him, he's done. He's got 2.
Is that only with hydrogen?
That's only with hydrogen. carbon wants 8. 2, 4, 6, 8. He's done.
Okay. Okay.
But hydrogen's the only one that wants 2.
Okay.
Okay, so now this isn't one of your resonance structures, though.
Oh,
These
that's
two
not
are.
part of it.
These two are.
So there's still another one?
No, it's just 2. Just 2 answers. It can go here or it can go there. Double bond can't go here because then you'd have 8, or so you'd have 10 around carbon. So it's only these 2 answers. That's it. So just, I would erase that, then you're good. Yeah. Yeah, perfect. Yeah, 3 lone pairs. Spaced them out all nice. It's easy to count. Yeah, it should be 35, 42. Now you're short. You have to have 22, right? They keep going on the center atom.
Oh, they do?
Yep. Just keep adding them there. Because it's, yeah, and you got, so you just make it so it's easy to see that there's 1, 2, 3 lone pairs. Like you got it. They're paired up. Yep.
Yes.
Okay. Okay. These 2 are right. This one's messed up because carbon is breaking the octet rule. 2, 4, 6, 8, 10. So you don't do that one.
I thought we could.
Only break the octet if you have to. And you don't have to. So just, that's okay, just erase this guy. And now it's bouncing between these 2.
Oh, okay. So how do we know when they do break the octet rule?
Yeah, that's what's coming up. So with this one right here, this is how I know that they break the octet rule. Is first it's not a resonance question because there's no carbon, nitrogen, oxygen, or sulfur. And then I count up the total. I've got 7 plus 7 plus 8. So that's 22. And which element goes in the middle, Daisy? Xe. Okay? Was surrounded by 2 Fs. So first thing you do is connect them, make octets on everything surrounding. Any electrons left over, you put where? In the middle. And that's breaking the octet rule, if you can, if you have to. Only if you have to. So I've used 16. I have to put on 6 more. That's 3 lone pairs. And pair them up so it's easy to see that they're lone pairs. You just keep putting them there until it's done. Until you've used them all up.
And then what do you do? Like in A, did we have to like give to the middle, or you already gave to the middle?
All the lone. If I have makes octets on the surrounding, so that's 8, and 8 is 16, 20, 22. So sorry, 16, 18, 20, 22. So I need 3 lone pairs on that center atom. And no double bonds, nothing, because it's not CNOS. So xenon's not obeying the octet rule. Xenon's got 2, 4, 6, 8, 10 electrons around it. It's just not obeying the octet rule. You have to live with it.
So it's like that.
It exists.
Okay.
And next class period, we're going to use that information to predict its shape. Mm-hmm. Yeah, he's just not obeying the octet rule. And you really want to make a double bond, right? But don't, because it's not CNOS. Good. Yeah, you just quit right here because it's not CNOS. You cannot make a double bond. No, that's too many electrons. All you've got is, well, you have 24. That is right. 24 is right. But you put 2 more, that's 26. Yep. You have a lone pair on? Yeah, you got a lone pair on there. It's just not obeying the octet rule. Good. Mm-hmm.
So then it's all of them have 8, and then this one
Yep.
has 2.
Anything, yep. And don't forget the brackets at the plus. Yeah, subtract 1 from the total. 42. Yep. Mm-hmm.
When you use these, is it only going to be for, how do you know when to use this and when to use
When you have CNOS first, right? And so you needed to make a double bond to give nitrogen an octet. But the point was, well, why not just do the double bond here? So then you did it. Oh, why not do the double bond here? So you did it. And stuff like this, you can't, anything left over, you just have to put on the center atom.
So anything that has the CNSO or C?
It has to have carbon, nitrogen, oxygen, and sulfur. Those are the only time you can draw double bonds.
But what if it has like sulfur, oxygen, and then...
Yeah, so you can only do double bonds between sulfur and oxygen. Like here, you can only draw double bonds between N and O and C and N. But just because you can doesn't mean you have to. Because if you draw a double bond between C and N, you're going to have 2, 4, 6, 8, 10 electrons. That won't work. So the double bond's only going to be here and here. There's only going to be 2 structures for that one. Okay. Well, that's really all I have. So if all these make sense to you,